Another enrichment packet for you, and this is a little bit more challenging than the ones we did earlier. They actually don't take as long, they just require a little bit more thought. This is a coffee manufacturer sells cinnamon coffee for $7 per pound and vanilla coffee for $10 per pound. At the end of the month, the cinnamon coffee had 30 pounds remaining. The store manager decides to mix those 30 pounds with the vanilla coffee. He sells a mixture for $8.50 per pound. How many pounds of vanilla coffee should be mixed to ensure no change in revenue? Now you're like, what the heck does that mean? Well, let's kind of follow our problem-solving plan, and then as it sets itself up, we'll kind of explain it. So I have 3 units, the cinnamon coffee, the vanilla coffee, and the dollars. So that's 3 units. So with 3 units, we want to format a table here to discover the relationship, because all 3 units relate to each other. So I have my total. And then how many means how many units do we have. The cost of a single unit and the total cost. Okay, so my 2 primary units, I've already addressed money. That's kind of your 3rd degree unit. And then cinnamon and vanilla are my 2 primary units. So cinnamon and vanilla, my 2 independent units. And the money's the dependent unit. Okay, now what we're going to do is go through this middle row first. Okay, how much does 1 single pound of cinnamon? Remember, this has to be cost. Okay. How much does a cinnamon coffee cost per pound? Well, $7. And also, instead of total right here, I want to write together. Okay, so together. So what we're doing with the 2 units is we're mixing them together. Okay, so I'm going to cross out 7. Now, how much does 1 single pound of the vanilla coffee cost? Well, that'd be $10 for a single unit or pound of vanilla. Now, I am going to mix these together. And how much do they cost for a single unit, a single pound, when you mix them together? Well, $8.50 per pound means it's the mixture together. So it's not often. Before, with the other problems, I would always kind of ignore that box, but not on this one. Okay, how many means your non-dollar amounts? Okay, well, the only thing I see for a non-dollar amount is 30. By the way, you see 2 30s, but that's just repeated information. And read through that sentence with the 30. At the end of the month, the cinnamon coffee had 30 pounds remaining. So 30 is not going to go here. 30 is how many pounds or how many units of cinnamon coffee you have. And I'm going to cross out the 30s. That means I'm unaware of how many pounds of vanilla we're going to mix with it. So it's X. Okay, and I really don't have any numbers, so I'm going to do what I can. So 30 times 7 is 210. That'd be 210 for the cinnamon. Then I don't know how many X units, vanilla units we have, but they cost $10 each, so that'd be 10X. And, whoa, what do I do here? Well, I know that together they're going to cost, when I mix them together, they cost $8.50 per pound. But I want to know how many units are going to be mixed together. Well, I know I have 30 pounds of the cinnamon coffee, and the vanilla coffee's X. Well, aren't you just taking 30 pounds and adding X onto it? I think you are. So that can be written as 30 plus X. So I put a 1 in front of the X, and now I can multiply using the distributive property. Okay, so I want to times both these, and I'm going to put this in the same box. So 30 times 850. Whoops, might help if I have a battery in my calculator. Okay, that give me 255 plus, then 1 times 850 is 8.50. It'd be 8.50x. I don't know why I'm punching that in. Now to have an X on it because this factor 1 had an X. Okay, now here's what they want to do. They want to know how much would, after how many vanilla pounds, the X, would selling these separate amounts equal when you sell them together? Okay, so I have 210 plus 10x equals 255 plus 8.50x. Now we can't really add the x's together because they're on opposite sides of the equation, so we'll pick one to get rid of. We'll get rid of the 850, so minus 8.50x minus 8.50x. Okay, so it's going to be 210 plus 1.5x equals 255. All right, then I'm going to go from there. So I can get rid of my 210. That's going to be 1.5x equals 45. And then I just divide by 1.5, and x is 30. And they're like, well, and people are like, well, how do you get the second answer? There is no second answer because there's only one thing I didn't know. The pounds, how many pounds of vanilla coffee. And now I know there's 30 pounds of vanilla coffee. And no, they're not always the same for how many. Okay. All right, next problem. A manager of a Starbucks store is mixing Colombian coffee, which sells for $5 per pound, with Arabica, or however you say that word. It's just a brand of coffee that sells for $10 per pound. At the end of the month, there are 30 pounds of the Arabica coffee left. The store manager decides to mix the remaining 50 pounds with some Colombian coffee. He decides to sell the new blend for $8.50 per pound. How many pounds of the Colombian coffee should be in the new mixture? Okay, so again, we have three units. We have the two independent units, the Colombian coffee, the Arabica coffee, and then the dependent unit, which is the cost. Okay, so the put together right there. And then how many? The cost for a single unit, and then the total cost. All right, so the two units, I have Colombian and Arabica, so C and A. So let's look at this middle row first. When we sell 1 pound of Colombian coffee, it costs $5. So I know that, no variable. When I sell the Arabica coffee, that's $10 per pound. And then I am going to mix them together here, and they're going to cost $8.50 per pound. Okay, now we're looking for non-money amounts here, and I see 50 pounds. That's just repeated information. It says, read the sentence. At the end of the month, there are 50 pounds of the Arabica coffee left. So we're not going to put 50 here. We're going to put it right here. Okay, and that means I really don't know how much Colombian coffee. That's my answer, what I'm trying to figure out here. And then, so that'd be 5x. 500 times 10 is 50 times 10 is 500. And then, well, how many pounds are we mixing together? Well, I don't know, but I know I'm taking X pounds of the Colombian and adding the 50 pounds of the Arabica to it. So 850 times X, that's a 1, and 50 times 8.50. So it's going to be 8.50X. I take 50 times 8.50, and that's 425. Okay, again, what we want to know is when the selling these just separately are going to equal when we sell them together. Okay, how many pounds of Colombian do I need? So I want to know when 5x plus 500 is going to equal $8.50 x plus 425. Okay, so the x's are like terms, so we can just get them together. You can also subtract that. I like to subtract the smaller one. So I have 500. 8.50 minus 5 is 3.5x, and then plus 425. Okay, and then I get the x by itself. I'm going to subtract 425. That's 75 equals 3.5x. I divide by 3.5. Okay, I got a decimal. That's okay. 21.4 equals X. Okay. So, again, that's the only thing I didn't know. So I'm going to mix about 21.5 pounds of Colombian coffee with the Arabica coffee, mix them together, charge them $8.50, and then I won't lose any revenue that way. Okay, candy store selling nuts for $5 per pound and almonds for $3 per pound. After the end of the month, the nuts had not sold well, and there are 30 pounds of those remaining. The store manager says mix the nuts with the cashews. He will be charging $4 per pound for the new mixture. How many pounds of almonds should he mix to ensure no change in revenue? So there's 3 units. Okay, and then put together. I should have been putting that all along in this class. Okay, and then how many? Single and total. And then the dependent units, the money. So I put money total, money single. And then I put nuts and almonds. So how much do the nuts cost for a single unit? So that'd be $5. So you can get rid of that. How much the almonds cost for a single unit? Well, 3. And then when we mix them together, okay, they're going to cost $4 per pound. All right, now up here, this is for non-money amounts. Because I don't really have a total cost here. That's why I'm not filling that in ever. So 30 pounds is the only how many, and you read it. It says at the end of the month, the nuts had not sold well, and there's 30 pounds remaining. So the 30 pounds is how many pounds of nuts you have. And I'm unaware of how many almonds I'm going to mix with it. So we're going to have $150 total dollars for the nuts. We're going to have 3x. And again, I know that I'm going to sell that when I mix them together, I'm going to be selling them for $4 per pound. But then how many pounds are there going to be? Well, I know there's 30 pounds of nuts plus X pounds of almonds, and that's 1X. And then I can go ahead and multiply that. So 30 times 4. 1x times 4, so that's 120 plus 4x. Okay, so I want to know when selling them separate are going to equal selling them together. So I want to know when 150 plus 3x is going to equal 120 plus 4x. Okay, so I get rid of the 3 by minusing it. So I have 150 equals 120 plus 1x, okay? And then I subtract 120. So it's 30 equals 1x. Okay, 30 divided by 1 is 30, so x is going to equal 30, okay? Again, 30, 30 mix, but it's not always the same. Like on the second one, again, I got 21.4. Well, that's not the same as 50, so they're different amounts.